Okay. So some of the other terms that we're going to need to know in this unit, one of them is mean, which is the average. So what I want you to do is take those test scores real quick and average them. You're going to add them and divide by how many you have. And then think about your answers to the questions on the screen. What would happen to the mean if the lowest data point were removed? Compare your answer with a neighbor. All right, what answers are you guys getting?
69.
You got 69. Anybody else get 69 as the average? You did? Yeah, it surprised me because I got that too, and then I was looking at it and I thought, well, 93, how could that be possibly be the average? But then I see that a lot of those are quite low, 47, 57, 55. So yeah, 69 is the average. Did anybody get the sum when you add them up? No. I think a lot of you put that in a spreadsheet, which is, what's that? 828?
Yeah.
Okay. So let's put this here. We said 828 divided by, how many were there? 12? Equals 69 is the average. So what would happen if the lowest data point were removed? What would happen to the average? It would increase. Yeah, that makes sense, right? The average would increase if we remove the lowest data point. All right, let's look at the middle, the median. So you're gonna need to arrange these in order and then find the median. Remember that if you have an odd number of numbers, then, oh, this should say even. If you have an odd number of numbers, you select the middle number. If you have an even number of numbers, then you're gonna average the two middle numbers. So you can put those in the middle anywhere you need to. Tiffany, are you remembering this? Like to find the median? Yeah, we're not on that example yet. All right, so this morning I tried to put them in order. You can tell me if I made any mistakes. Let's take a look. Look over my work, make sure I didn't make any mistakes. And then we'll find the median if this looks good to you. I think I got that there were 12 numbers. Is that what you guys got? 12 numbers? Okay. Oh, it's the same numbers, right? All right. And then, so there were two numbers in the middle, and you would average them, except it turns out it's pretty easy to average them because they're both 64, right? So when you see that they're both 64, please don't add them together and divide by 2. Like you should be thinking, okay, the average of 64 and 64 is 64. Just save yourself that step. All right, let's see. Standard deviation. So we are going to be calculating standard deviation with the spreadsheet, and it is a measure of dispersion. It's a much better measure of dispersion than the range. because it's not just talking about the minimum and the maximum, but it's talking about all of the data, how spread out all of the data are. So let's look at the example there. If I told you that the 6th period class had a mean project rate of 80% and a standard deviation of 5%, but the 8th period class had a mean grade of 80% and a standard deviation of 10%, what conclusion could you draw from that? Raise your hand if you can share an idea. What would that mean if they had the same mean, but 6th period had standard deviation of 5, and 8th period had standard deviation of 10? I see one hand. I'm waiting for a few more. Nope, that was just a back scratch. 2 hands. I'm waiting for a few more hands. Kind of intuitive, so if you're thinking, I think I know, but I'm not sure, just raise your hand. No big deal. Okay, go ahead.
So it means that for like most people got it in at like the average would be like 80%, but it was for the first group, it was closer to 80,
Okay.
like 5% away, so probably like 5 numbers, so 75 to 85 would be like where most of them people were.
Okay.
And then for the 8th period class, it's 70 to 90 where most people were.
Okay.
So it's a wider spread.
A wider spread, and it looks like you need to add to that.
I have a question.
Yeah.
So is it, is the 5%, like, is it a unit, is it like 80 plus or minus 5%, or is it 5% of 80 either way?
Oh, I see what you're saying.
Yeah.
We're gonna ignore the fact that it says percent there, we're gonna just treat it as a number. So, I don't know how much you remember, and some of you in Algebra 2 may not have learned this because of the last couple of years Algebra 2 has been a little bit condensed. But there's something called a normal curve, and the normal curve has 3 standard deviations, and then after that you've got outliers. So if you look at this, this is 1 standard deviation below and 1 standard deviation above. So what Kenneth was telling us is that most people scored 5% below 80 or 5% above 80 in 6th period. That's true, because you see how most people are in the middle, right? And then in 8th period, most people scored between 70 and 90. They're a little bit more spread out. That's not all people, that's just most people there. So basically, the scores in 8th period are more spread out. 6th period, maybe they've got like a 6th period study group or something, because they really scored really close together. All right. So you can find these things in Google Sheets, and let's just try that together. So I'm going to move this up. You can open a Google Sheet and copy the data in. Some of you have already done that. All right, and let's look at these formulas. You can actually even copy that. Equals average, or you can just type it. That did not work. Let me try equals average. And then he says to highlight your data. Yeah. Do I need this? There we go. So what I did was I did equals average. I had the parentheses, and then I clicked inside the parentheses and highlighted the data, and then I press enter. You can actually also just type that. So see how it says A1 colon A12? Here's A1 and here's A12, and that means like everything from A1 to A12. So the average, some of you knew how to do that. Median, so you'll do equals median and then highlight your data. So equals median, parentheses like that. Click inside of it, and then remember, don't highlight this one in this row because that was the average. All right, so I got 64 for the median, which is what we got. And standard deviation, we don't have that one yet. It's STDEV. And I highly suggest you guys do this so that you'll be ready when you need this for your project. All right. I got 15.2. Did anybody else get 15.2? Kylie? Just paste it into the first box before. Is that what you do? So what I would do is try highlighting 12 boxes and see if that works. Try? No, it's not that one. The average height. I don't even know what that is. Okay. Alright, so height equals average. Okay, you're using that one, it's fine. Alright, now highlight the data. Yeah. Yeah, I can give you 69. Alright, any questions on finding the standard deviation? Are you good? Alright. Any questions? Okay. Alright, 2-minute brain break. And then we're going to do some box and whiskers plots. Byron. Okay. So, what we are looking at here, let's set the phones down. What we're looking at here is a box and whiskers plot. So, the box is the middle 50% of the data, and the whiskers are the top 25 and the lowest 25. Let's set all the phones down. So there are 5 important points on the box and whiskers plot. The least value, which we also call the minimum. The first quartile, which we write as Q1. The median, it says here Q2. No one ever calls it Q2. It's always called the median, but technically Q2 is right. The third quartile is at the end of the box, that's Q3. And then at the end of the whisker is the greatest value, which is the maximum. 25% of your data are in each section. Sometimes one part of the box looks bigger than the other, and people conceptually have trouble with that. Like, how could that be 25% and the other is also 25% when the two parts of the box are different sizes? That just means that the 25% on the left is more spread out than the 25% on the right. So there's the same amount of data, but the part on the right here is much more compact. Their numbers are closer together. Let's see. I believe that's everything that's on this slide. So let's go to the next one. Okay. So now we are looking at a box and whiskers plot of heights of girls and boys. And there are some questions. And the first question is, which group had the higher median? And then the second one, what percentage of boys measure less than 66 inches? The third one, which group is more consistent in their heights? How can you tell? Is there a more reliable way to determine this? All right, so take a minute to consider those questions. Which group had the higher median? Ireland. Do you guys agree the girls had the higher median? Yeah. So the girls had a median of 67 and the boys were 66. So let's add that answer. What percentage of boys measure less than 66 inches? Raise your hand if you have an answer for that one. Olivia. 50%? Anybody else want 50%? I see some head nods. Okay, good. All right. So because 66 inches is the median, that means half are above it and half are below it. Which group is more consistent in their heights? That's the first question. Which group is more consistent in their heights? Raise your hand if you think the girls are more consistent. All right, raise your hand if you think the boys are more consistent. So we had some votes for girls. Raise your hand if you can explain how you can tell the girls are more consistent. I see one hand, two hands. Kyle?
The box, or, yeah, the box with the whiskers aren't required.
The box and the whiskers aren't as wide. Is that what you're going to say, Ireland? Okay, good. So let's add those there. So we said the most consistent was the girls. Make this bigger. The box and whiskers were less wide. All right, and is there a more reliable way to determine this? What calculation could we make, Arland? Excellent. Yes, we could compare their standard deviations. So we'll put that there. Okay. Let's see. Number 12 is talking about interquartile range. So more important than the range of all of the data is the range of the middle of the data. And so in our last project, we found the range of all of the data. And in this project, we're going to talk about the range, the interquartile range. And that's going to be Q3 minus Q1. It's basically the range of the box. So take a minute to calculate the interquartile range, and I will read to you the numbers here. The minimum is 8, Q1 is 15, median is 20, Q3 is 25, and the maximum is 27. And so remember, interquartile range will be Q3 minus Q1. Here are the numbers one more time. Minimum is 8, Q1 15, median is 20, Q3 is 25, and the maximum is 27. Raise your hand if you would like to share the interquartile range. I see 2 hands. I see 4 hands. Kumar, what do you have?
10.
Anybody else get 10? Excellent. Okay, so we did 25 minus 15 there. And then the statistical range is still the maximum minus the minimum. Has anybody calculated the statistical range? Adam? 19, okay. So that would be 27 minus 8 is 19. All right, good teamwork there. All right, so we have briefly mentioned that outliers can be 3 standard deviations from the mean when we're talking about a normal distribution like the one I drew on the board. But when you're doing box and whiskers plots, you don't have a normal distribution like this. So we have another definition, which is an outlier is going to be 1.5 IQRs, interquartile ranges, above Q3, or 1.5 IQRs below Q1. That's like a lot of letters, so it sounds weird, but it's a pretty simple calculation, and we'll do this one together. I think we have an example here. So on slide 14, we have distance to recycling site in miles. And I have a list of numbers, 12, 15, 16, 12, 11, 19, 15, 16, 14, 29, 11, 12, and 13. We are going to put these numbers into Desmos, and we're going to make a box plot in Desmos. Google Sheets makes something called a candlestick graph, but it doesn't have the median on it, so Google Sheets is not a good one for this. But down here it says Desmos identifies 29 as an outlier. Use what you've learned about outliers to prove that this is an outlier. So we are going to go back to this definition, and we're going to use that. All right, so in Desmos, where are we? We're going to do L equals and then a square bracket, and then we're going to list the numbers with commas in between and close the square brackets. There's a little video here, but it's basically saying the same thing. The screenshot, I think, is the most helpful. Yeah, so I see a lot of you are copying the data, which is good. I don't know if there is an easy way to get that into Desmos because it's vertical and we need horizontal. Raise your hand, though, if you found something that makes it easy. I'm going to take you a minute because I want to give you time to get this into Desmos. So you go to desmos.com and you're choosing the graphing calculator. and you're gonna do capital L equals square bracket and then the list with the commas in between. I'm gonna go back so that you can see the list. Capital L equals square brackets and then the list with the commas. I'm gonna be in Desmos right now. You're gonna need to make these box plots for your project, so it's really important that you know how to do it. Desmos.com. Yeah. We're gonna do that in a second.
Oh, so this is
Yeah. I don't even know what phone you're having.
You said it was capital L.
Yeah. Yeah, if it says you have a 13 element list, you should be good. Good. Amar, you got it?
Yep.
Or Desmond? Nice. Alright, so then in the next line, we're gonna do box plot, parentheses, capital L, close parentheses. And it should make a box plot. The thing is, you don't see it right away because your window's not showing those numbers. So we'll fix that. All right, so we need another line, and then box plot L. Okay. Right now I have exclude outliers checked. What I'm going to do is I'm going to drag the Desmos over so that I can see the graph. And on the slide it said Desmos identified 29 as an outlier. You can see 29 is not on the graph. Some people like to exclude the outliers. Some prefer not to exclude the outliers. For your project, I would uncheck that box. But for now, we have it checked so that we can figure out the rest of this. So bless you, our box plot has a minimum of 11, first quartile 12, median 14, third quartile 16, and a maximum of 19 because we excluded the outliers. What is our interquartile range? I heard something, but I don't know what it is. Yes? Anybody else get 4? Okay. So our interquartile range is 4. So anything that is more than 1.5 interquartile ranges from Q3 is an outlier. So what is 1.5 times 4? 6, okay? And so if it's more than 16, it would be an outlier. So if it's more than 22, it would be an outlier. All right, so I'm going back. Okay, so the interquartile range we said was 4, and the Q3 was 16. And so that means, I'm going to make this bigger so I can keep typing. So if we want to do Q3 plus, I lost my plus. Oh, there you go. 1.5 times IQR. That gives us 22. So 29 is too big. Okay? All right, so now we're going to analyze the graph. We want to know the middle 50% are between what, the closest 25% are between what, and the farthest 25% are between what. So I'm going to go to my Desmos. Middle 50% between 12 and 16, the same numbers we used for IQR. How about the bottom 25%? Between what two numbers? 11 and 12. Good. So let's get that on there. We said 12 and 16, right? 11 and 12. Now how about the farthest? What do you guys get for that? 16 and 19. Yep. Okay. I want to know what questions you have. Anybody have a question? Or just want me to review something again? Go ahead.
Are we excluding the outlier for this
Yes, so for this problem, we did exclude the outlier because that is what Desmos did, and we decided that's how we were gonna go with this one, but on your project, you don't exclude the outlier. Good question. Okay. We're gonna talk about line graphs, and then after we talk about line graphs, I'm gonna give you guys some problems. We'll do some together, and some you'll do on your own for box and whiskers. So line graphs can be used to illustrate observations against the time at which they're measured. You do not use SOCs for line graphs. We're going to talk about local maximums and minimums, absolute maximums and minimums, and also overall trend, which is not on here, but I'm adding it. Okay. So in this graph, we see the number of push-ups somebody did each day. So on Sunday, it looks like about 4, Monday 10, Tuesday 5, Wednesday 10, Thursday 15, Friday 16. Okay, I'm a little bit off, but you get the idea. And Saturday, maybe 21. Okay, so the overall trend, if you start Sunday at 4 and you end Saturday at 21, I want to know if you think that would be a positive or a negative trend. What do you guys think? Yeah, it's an overall positive trend. Even though it had some dips, it was an overall positive trend. Local maximums and local minimums are just the highest point in an area, not the whole thing. They're tricky, but basically if you have a peak, that's a local max. Which day do you think was a local max? Monday was a local max. So I'm going to write 10 on Monday. The Y value is the actual maximum. And then a local min is going to be what on which day? Yeah, 5 on Tuesday? 5 on Tuesday. Absolute maximum is the biggest overall. Which day did he do the biggest overall, or she? Saturday. That was so sexist. Why did I say he? My daughter's been doing push-ups. She wants to get better at swimming. 21 on Saturday. And absolute minimum, which day? Sunday. How many do you think that is? 4. Okay, 4 on Sunday. All right, good. All right, and actually I am gonna, well, oh yeah, we want to do this in Google Sheets. So I do want us to do this in Google Sheets because we haven't made a line graph in Google Sheets yet. You can go to the same spreadsheet that we were calculating on before and just click the plus to get a new sheet on it. And what we're going to do is we're going to put the ice cream sales into it. So I'm going to give that title in A1, ice cream sales. Ice cream sales. And then I believe we're doing the days, Monday through Sunday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And then we'll put in the numbers. Welcome to Tabibu. Tabibu, did you check in at the sub school? Good. Okay, you can leave it here. And then you can get onto Schoology. Be careful there. Good. Thank you. 410, 440, 550. $420, $610. $790, $770. All right, and then once you have that, we're going to highlight it and make a line graph out of it. Insert chart.
What?
And I don't want a pie chart, I want a line graph. Oh, 41, that kind of messed me up. Thanks, Kyle. 410. Do I need to redo this? I thought it would just redo it automatically. All right, thanks. Okay.
That's where the round
I do want to label my axes. It's mostly labeled, but I need to label my vertical. And you're going to want to practice doing this too, so you'll need it when we're ready for it. So, sales in dollars. And then horizontal should be days. Okay. All right, so our chart started at 410, it went up to 440, up to 550, down to 420, up to 610, up to 790, and then down to 770. So overall, is that a positive or a negative trend? Positive? And I'm just going to do absolutes right now. We know how to do the locals. So you had an absolute maximum of what? $790. Good. And that was on Saturday. And an absolute minimum of, what was the minimum? 410. Good. It's close on Monday. Now you can put the locals in there too. I'm just trying to get to the part where we get to do the paper. So I'm actually going to start your 2-minute break now, but I'm going to leave that slide up for those of you who are still working on it. You can ask questions while I come around with some paper for you.
Put it as $10.
Yeah, sorry about that. 410, right?
Yeah.
I appreciate you guys, because some people will just let me type the wrong thing. We'll just leave it there.
If it's a new car, it like doesn't have mileage at all. Because if this doesn't say anywhere. what
If
it
it's
is, so
brand new, I think you could assume it's 0.
Okay.
Did you Wyatt sent you an email about party? Okay. You did send it, right? What?
Yeah.
This is already checking. All these models are like 20. I mean, it's okay.
I'm gonna give you this paper, the back of the paper is what's on your braille, right? The back of the paper, I did not have it ready to sign, but I will give it to you anyway. We're gonna do this together on the front, and then you'll do them on the back. Alright guys, you will need something to write with. If you are missing a writing utensil, I have some on the bottom shelf of my shelves over by the window. Maybelline, is your computer working all right? Good. Everybody has a piece of paper from me, right? Okay. All right, so we're gonna make box plots by hand. The reason why we practice making them by hand, even though we're doing them on the computer, is that we want you to have an understanding of where they come from, and not just that, you know, the computer makes this magic box plot. I think I have some rulers if you want to make them look nice. I'm just gonna take a quick look to see what I did with my rulers. They might be in here. Yes, they are. Okay. I'm gonna say, if you want a ruler, I'm gonna put them here by Mohammed, so just go ahead and grab one if you want one. I might not have enough for everybody, so you might need to share with a neighbor. Okay. 5-number summary and the mean. So 5-number summary is the minimum, Q1, median, Q3, and maximum. So we have to put the numbers in order for that. So I'm going to do that. If I make a mistake, just stop me. I feel like that's too many numbers. 1, 2, 3, 4, 5, 6, 7. Nope, I did it right. I think, yeah? Okay. All right, so this is the median. The Q1 is in the middle of the first half, so you can see what's in the middle of the first half. And then the Q3 is in the middle of the second half. Doesn't always come out so nice and neat, but this one's pretty good. Okay? I don't know why it's so blurry. I would like it to focus. I don't want to zoom. I don't want to change the camera to me. This one? Let's try higher resolution. It's not that great. Oh well. Usually it like tries to focus in and out. Yeah, like that. Beautiful. All right, and then the minimum is, you can see, the smallest, and the maximum is the largest. So we know all of the numbers. So we had the numbers 4, 4, 6, 6, 7, 8, 9, and we had a minimum of 4, first quartile of 4, median of 6, third quartile of 8, and maximum of 9. We're going to do the interquartile range, so Q3 minus Q1, 8 minus 4, and we get 4. And it asks, are there any outliers? Are there any numbers that are lower than Q3 minus 1.5 IQR? Sorry, Q1 minus 1.5 IQR. So that would be 4 minus 1.5 times 4, 4 minus 6. So there are no numbers lower than -2, so we're good. And then Q3 plus 1.5 IQR, 8 plus 1.5 times 4, 8 plus 6 is 14. No numbers that are higher than 14, so we're good. All right, questions so far? I see a lot of people writing, so while you're writing, I'm going to set up a number line for my box plot. And this is what I'm using the ruler for. I want to have like nice, neat intervals on my line. So the box plot only has an x-axis. It doesn't have a y-axis. It doesn't have to start at 0, but you can't skip numbers. So I'm going to start my x-axis at 4. Yes. Go ahead. Oh, there are some next to Mohammed if you like. Over there, right there. Yeah. Okay. All right, so notice our minimum and our first quartile are the same number. That happens sometimes. It means you don't have a whisker. And then our median is 6. And Gabe, this is the one that's on your first page, actually your second page of Braille, the first graph though. And then your third quartile is 8. And your maximum is 9. So because our minimum and our first quartile are the same number, we don't have a left whisker. I'm drawing the box around 4 to 8, and then there's a line in the middle of the box at 6. The right whisker goes from 8 to 9. And then notice sometimes people miss these words, and then analyze the graph. So to analyze it, we're just going to say like what we've noticed. The middle 50% of the data are from 4 to 8. And then the top 25% of the data are from 8 to 9. This is a weird graph because they're also saying 25% of the data is exactly at 4. Now, because this number is not, this number is 7 data points and not 8, it doesn't work out exactly, like if you look at it, that it's going to land in 50%, but it is about right. I'm going to do one more example, and then on the back, you guys get to work on those without listening to me. So here's example 2, and Gabe, you have this one as well. For this one, it says find the 5-number summary and the mean. Oh, we never found the mean of those numbers. Did anybody else find it yet? You did? What did you find? 6.29. Did anybody else get 6.29? Okay, so we will verify that then. So I'm looking at the numbers, adding them, I get 10, 20, and then another 15 is 35, and then a 9 is 46. So I have 46 divided by 7, and let's see if we get the same thing. Oh, I'm just going to use my phone. Anybody already calculate it? 6.4? Oh, you got, say it again? 44? Yeah, you're right. 44? Okay. 44 divided by 7. Yep, I get the same as Adam, 6.29. Thanks for helping me add, guys. Okay, so we're doing 5-number summary and mean of the next group of numbers. We have to start by putting them in order. 3, 4, 5, 6, 9, 16. And we have 2 numbers in the middle. When you have 2 numbers in the middle, you're going to average them to find your median. So what is our median? Yeah, actually, I'm going to write it over here. Median equals 5.5. Now, when you have 2 numbers in the middle, you just have a line here in the middle, and so I'm still using 3, 4, 5 to find the first quartile. So 4 is my Q1, and 9 is my Q3. And then I have a minimum of 3. And I have a maximum of 16. All right, if you're curious, you could figure out whether 16 is an outlier, but just like we're going to do on the project, we're going to include it regardless. And I'm going to make a number line that goes from 3 to 16. When you have a lot of numbers, you don't have to write every number, but like if you were to write every number, it should work out. So your scale should still be consistent. So for example, like I could mark the first one 3, not write anything on the second one, and then write the next one 5. And that can tell that I just didn't go quite far enough. I needed to go to 16. All right, so I have my minimum at 3, that's a dot. And then I'm gonna make a dot at 4, my Q1. And a dot at 5.5, my median. A dot at 9, which is my Q3. And then a dot at 16, which is my maximum. And then around the middle 3 dots, I do the box with the line that goes through the median. And then I do a whisker that goes from Q3 to the maximum, and a whisker that goes from the minimum to Q1. And then to analyze it, I will say what percent is in each section. So I have 25% from 3 to 4, 50% from 4 to 9, and I have 25% from 9 to 16. Okay, so I'm going to be turning off my recording so you have some time to work on the problems on the back. What questions do you guys have before I do that? All right, so go ahead and work on those problems on the back. These are going to be the notes that you will find useful for your check-in next week. So not only do you want to do these practice problems, but you also want to save them someplace in a folder so that they'll be accessible on Wednesday next week.